Yeah, hi. Good evening, everyone. Welcome to the second session of week 2. Uh, okay, so I hope you have watched the videos and you tried to solve the questions. So this week is basically to just recap of the C programming. So what are the useful for the embedded system? So if do you have any query in the questions topic? If you have any doubt, because till now we haven't started any like demo or that controller microcontroller interface things. This week is just what are the required things you should know before starting this embedded C programming. So week 3 onwards, actually, we professor will give some demos on the simulator which we are using in this course, that that workflow, and how basically we write the code, how we actually connect the hardware. So some type of demo professor will give, and then how you can start the emergency programming on the hardware. So before that, but you should know the basic required concept from the C, actually, which are very important for this course. First is that pointers. Okay, so that pointer we have already learned in the C programming course. So good knowledge of the pointers. Another is the very important topic is bit manipulation. So that is also required because we generally when we want to connect or interface the interact with the hardware, this microcontroller. So many times we require this bit manipulation to just update the value for any particular bit, reset the value, set the value. So because of that, we introduce some programming question based on that, where the some terminology is also related to the embedded programming: set bit, reset bit, toggle bit. So these terminology is actually very important, and when you are just interacting with the microcontroller. So if anyone have any query in assignment questions or any in these topics, bit manipulation, pointers, or any topic in the C, because the general topic like loop function, that control statement, that is a general in the coding, that should also. So any specific doubt in any question, practice assignments? Okay, am I audible?
Yes.
Okay, fine. So there is no doubt in the assignments question and this bit manipulation, uh, or you haven't watched the content till now? What should I understand?
Uh, hello,
Yeah,
sir.
Venkta. Yeah, go ahead.
Actually, I'm much clear with the content, but it would be more helpful if you can once revisit the concepts of dynamic memory allocation from C.
Dynamic memory allocation. Okay,
Yeah.
okay, okay. One second. Let me share my screen. Okay. So dynamic, first thing, what is the purpose of dynamic memory allocation? Let's. I have one document also. Let's open that document. One second. It will be helpful. Okay. So dynamic memory allocation basically we used when we initially don't know what size actually we require to store the data. Suppose if we are getting some data at the runtime when our program is actually running. Okay, so at the running time we are getting some input and we don't know how much input we will receive at the runtime. So at that this type of situation when we don't know initially that how much the maximum size we required at the running time, so we use this dynamic memory allocation. So another type of memory allocation is static memory allocation, where we know that how much memory is required at the running time when we are running any program. So at that time we generally use some data structure where we can allocate the size. Like if suppose if you want to store some data, like 100 data you want to store, so initially you know that 100 elements will be come in the runtime, or maybe at the runtime. So you can store, you can allocate, you can initialize the memory at the compile time with the 100 element. Like you can just take an array of 100 elements, and you can just pass that array to at the compile time, that that memory I will allocate, and you can use that memory. But you don't, if you don't know how many elements will come to store that, you what you can do, you can use the dynamic memory allocation. So dynamic memory allocation means when your program is running, at that time you will request to the compiler that allocate some memory, and you can use that memory. After that, if you feel that you have done and there is no requirement of that memory which you asked for the compiler, and now you already used it, then you can also free that memory at the runtime. Okay, so both operation are performs are the on the runtime actually when our program is running. So memory allocation and the deallocation, we can see that there is one more operation we have, that reallocation. That means we can also increase the size which we have allocated previously. We can increment the size at the running time. So basically we have three four function in our C language. So first is actually this malloc function. So this function is actually provides a memory block. And what is the syntax of this malloc function? You can see in the editor here. So let me just draw this. So this malloc is the syntax keyword, and inside this we pass one argument. So this is basically a one argument we have, where what we are giving, if you know the total size in bytes. Okay, suppose if you know the 40 bytes you require. Okay, so you can also pass this 40 value to inside this malloc function. But if you don't know the what is the total calculated size, what you can do, if you know what type of element you want to store, like integer, okay, and how many elements you want to store. Okay, so and you also don't know what is the size of integer, so what you can do, you can just write this function size of int. So this function will calculate the size of int what the compiler is taking. So suppose 4 byte is it is taking. So and you can pass how many numbers of elements you want to allocate. So that you can pass 5. So 5 into 4, 20 bytes will be allocate uh, for the program at the runtime when this instruction will execute. Okay, so this instruction will be written inside the code. When this instruction will execute, so this instruction will allocate memory of 20 bytes block, and the address of that memory will be assigned to this pointer number. Okay, so this is an integer pointer, so that means we this number is a pointer that contains the address of the memory. That memory contains the integer element. Okay, so before, because this malloc is always provide the void type of pointer, so we have to typecast this to the integer pointer. Okay, so if we are if we want to store the address in the integer pointer, so we have to we have to typecast this void address into the integer address. Okay, so integer pointer address. So because of that we are doing this typecasting. So this malloc function will provide, and then we can use this memory block to store our data, like this program is given. Okay, so this program you can see here what we have, this pointer, and we have n equal to 5. and we are just calling this function ptr equal to this malloc and into size of this. So what we are doing, we are allocating 5 into 4 byte this memory allocation, and that memory allocation, that address will come into the ptr. After that we can use this memory allocation like as an array. So this is the safety purpose block. If suppose sometimes if our memories are totally used in some another operations, and this instruction is actually not able to allocate the memory at the runtime, so what happened, this will return null. This will return null address to the ptr. So that means memory is not allocated if we are getting this ptr equal to null. Okay, so we can just print this message for the safety purpose, because here, and we will return 1. So that means we are stopping our program at this stage because memory is not allocated. So this condition we can just use for the safety purpose. After that, if memory is allocated, then we can simply use that memory allocation. So this is a block like for the that yeah. So 5 elements, suppose. Okay, so we have this block of memory and initial address. Suppose this address is 1000, and this address will be allocated to the ptr. ptr is 1000, and after that, when you add this 1000 plus 4, you will get the address of next element. Okay, so that means the second element address. So in that way you can add this address to the base address, and you can access all the element which is stored in this block. So we, similar to the array operations, we can access the element, we can store the element. So here you can see we are running a loop I equal to 0, and if you know the pointer arithmetic, so what we are doing in this ptr of I equal to I into 2. Okay, so we are storing the data. Okay, when we can also access in this manner. Okay, so ptr inside the bracket we can pass the I. So internally it will calculate the address of the next address based on the I value. So if I equal to 0, so that means base address uh, plus 0 into 4 byte. Okay, so that means 0, and the address will remain 1000 base address. If I equal to 1, that means 1000 plus 1 into 4. So this operation will be performed internally, and you will get the address of the next element, next block. Okay, so you can directly use in this manner. Otherwise you can also do this pointer arithmetic like this ptr plus I, like this operation. Okay, so here you are adding, if you are adding this like 1000, and plus if you are adding 1, so this 1 will be considered as a 4 byte, because you are adding integer value. This is an integer, and this is the address. So when you are adding this integer value, so by default this 4 byte equivalent size will be added into the address. So 4 byte will be added into the address, and you will get the address of the next element. So you can also access the element with the help of this pointer arithmetic. Okay, so in this way you can use your memory, and once you feel that your purpose is completed, your task is completed, then what you can do, you can free the memory. Okay, so this free operation is basically for deallocate the memory. Okay, so what memory you allocated at the runtime, you can also deallocate the memory. So this is very good practice in the embedded system. If you are using dynamic memory allocation at any point, so also you use this operation free. That means you use the deallocate. Otherwise, have a professor have already mentioned in week 2 that fragmentation issue. Actually, that issue will come, or that issue is different actually, but this maybe create some problem if you are not deallocating the memory. So that will actually use the memory, and if you are not using that memory, so that is actually waste. So this is not the optimized things, because we have the limited memory in our embedded system. Okay, so we should try to make the use of the memory as minimum as possible. Okay, so otherwise because we have limited memory, we cannot have too much memory like in our general system. Okay, so we will use our memory efficiently. Okay, so this is the one operation malloc we can use as a dynamic memory allocation. Another operation we have calloc. Okay, so this is also a allocation function similar to malloc, but here it actually allocate the memory in blocks. Okay. So in blocks, and also what is the difference between malloc and calloc? So calloc is also initialize the value in uh, the allocated blocks. Okay. So here we have two arguments. You can see in the syntax of this calloc 20 we are passing. So these two argument you can see separated by the comma. So first is number of elements, second is size of the each element. So suppose if we want to allocate some 20 characters space, so first we have to pass the size of each character and number of characters. So these we will pass separately, and 20 blocks will be allocated continuously, and the address of the first block will be returned to this pointer name. Okay, so we have to use the typecast thing here also, because here what type of pointer we are taking, so we are taking character pointer, so we have to typecast our void pointer into the character pointer. Okay, so then we can use that character. So here that memory blocks, so 20 blocks memory will be also initialized with 0 in the each field. That was not the case of the previous malloc. Okay, so this is here initialize. So you can see this allocated memory is set to 0. Okay, ensuring a clean state of the storing strings or other data. So this is also one another type. You can also use this calloc in your code, so similar to the previous code. So this is also the same code, but here we are using this calloc, and here we are passing the two arguments instead of one argument. So same way you can also access the memory, and you can store the memory. You can just update the things in the similar way of like array or point using the pointer arithmetic. And this is the main required things. After use, just free this memory. And last operation, we have this realloc operation. So realloc, suppose if you allocated some memory, and during the operation you feel that you allocated less memory and you want to increase that memory. So that memory you can use this realloc operation, and this realloc operation takes the number and this okay, so this how many elements you want to store, and okay, so this number is actually a pointer, not this is not a number of elements. So what previously we have allocated the memory, and the address of that memory block is stored in this numbers. Okay, and we want to reallocate this memory here. Okay, so we will pass the pointer first, which is actually contain the address of the previous memory block, and after that we will pass the new size. Okay, so what is the new size of our memory block? So suppose if in the previous you can see we allocated the 5 integer element size, but we want to increment this, so that means we have allocated 5 block of the integer, but we want to increase this into the 10th block. So we will call this realloc function, we will pass the pointer, and we will pass the new size. So new size, that means the memory will allocated 5 more blocks, and this will be added. So if any previous data is stored in this 5 blocks, so that will retain stored. Okay, that will not loss. So sometimes what happen, if continuous memory is not available, most of the time if memory is free, then this continuous memory will be allocated of the previous memory. Otherwise, if continuous memory is not allocated, new memory block will be allocated completely, okay, from the first position, and this in the previous element which is already stored in this location, so that will actually copy to the location first locations, and the remaining location will be empty. Okay, so you can use that location later, but your data will not be lost. Okay, with the help with when you are using this realloc operation. So this realloc operation, same things, this is just a reallocation. So same way we can use any place in the code if you want to use. Okay, so this is here you can see we have allocated this operation first time. After that, we after some performing some operations, so we have also stored the data, and later we increase the size to the 10 integer, and later we can also access or update our elements. So here we update the elements, and last time we will free this address. So this is actually a dynamic memory allocation. So this free is the very important operation. You should just free your memory. Otherwise, what will happen? Suppose if any pointer contain the address, like if any ptr contain the address of any memory allocations. Okay, so and what so yeah, that definition is also given this what is dangling pointer. So suppose if you free the memory, this is another pointer, and the same memory address you have in another pointer, like this is ptr and this is ptr1, and this is allocated memory. Okay, and suppose if you free this memory using with the help of this ptr1, but still this ptr also contain the address of this memory which is allocated previously, but now you have already free. So this pointer is actually called as a dangling pointer because it is still contain the address of the previously allocated memory, but that is you which you have already deallocated, that should not be used in the program. So that it maybe create some problems when you are using this pointer. So that is called as a dangling pointer. Okay, so this is all about the dynamic memory allocation. So you can use at any place like 2D array. So some big 9 in C programming we have discussed this, how we can allocate it the array or 2D array, how we can use. Okay, so any query in this? Those who have asked about this dynamic memory allocation.
Yeah, sir. It's clear right now.
Okay. Okay, any other topic like this bit manipulation? This is actually very important in this week 2. So yesterday, I think question number 8, some of them have doubt. Is it clear or not? Practice assignment. Question number 8. This. Anyone have any doubt in this? Okay, nobody's speaking. Okay, any other doubt or general doubt? Any you if you have?
Sir, will we be having Linux in this course? Like working with using Linux?
Not too much. Sometimes some commands actually we can use to run the code or like this. Okay, so, sometimes maybe professor is explaining something, so they can use the Linux command to run something. So because of that, this Linux things is required. You should know that what is that command.
Sir, I have a doubt regarding the realloc function.
Okay, what's your doubt?
Um, you already told that if we reallocate a memory size larger than what we had allocated before, then the
Hmm.
original value will be copied.
Hmm.
What if we reallocate a value that's smaller than the original, sir?
Generally, this reallocation is not happen for the smaller. So we not free the memory like half of the part. This type of operation is not supported. Yeah, that is possible, but what happened actually that memory will be freed. So some part of the memory will be freed, and okay, we can check also. So just wait, because I am also not tried this less memory reallocation. So let me check what type of the behavior of the compiler if we are using this operation. So just give it a minute. Okay, so this is the code we have where we are allocating 5 initially. Okay, and we are storing the data, and after that we are allocating. Okay, so what will happen if I allocated this 3? Okay, so okay, then what we are doing, we are, so we should, okay, so let's run this. Yeah, it is giving the output. It is not giving the error, but there may be a problem. So 10 elements. Uh, Let's just make this. Still, it is running. So what happened actually? This is the disadvantage of the C. Actually, this is the pointer things. Because of that, the another higher level language it not use this programming, this pointer concept. Okay. So what we are doing, we have allocated only 5 blocks here, but still because the address are continuous. Okay. So if we know the base address, if we add the 4 byte, we will get the next address. Okay. And still you can see we are just storing the data till 10 place. Okay, but we have allocated in the memory only 5 blocks, but still this compiler is giving the access of the remaining blocks of our code. But it may be create some crashing things. So suppose the same memory block is used by some another operations, so in that case it may be crash. But if that memory is free, that your code is actually accessing that memory, and you are updating the values on that. Okay, so don't use that, because here it is running. Sometimes it may be fail if that memory is allocated. So after like this 10 this address, maybe that memory is allocated to the another function, another operation. So in that case, that your operation will be failed. This program will be crash, because this memory is not allocated to your program right now, but still you are accessing the memory blocks. Okay.
Okay, sir. One more
Huh.
doubt I had, sir.
Yes.
Uh, can we use the free command to free memory after a certain point? So let's say free pointer in square brackets we put 2.
You can
So
free this pointer in at any place, but still same things. If you free and later you are accessing the same memory location by another pointer, like this dangling pointer, you can access. Maybe compiler will not stop you. Okay, let's check this. So these are the drawback of the actually language. Okay,
so
so we
what I wanted to
one
what I
second.
meant was can we use free like a free pointer and in that pointer we choose the second position. So we put brackets 1. So would that free after the second position or would that free the entire pointer?
Okay, so you are saying that if we pass the pointer like ptr plus 2, so the base address plus 2, so that means from the just give me one second. So you are saying that after first 2 elements, the remaining memory will be free. You are saying that if you are
In the
passing
sense
this.
that in the for loop we use ptr brackets I to select the position that we want after the first, position of the first element.
Like this, you are saying that 2 in this way.
Yes, sir. Yes, sir. So what would this do, sir?
Still reflection will not be visible. Maybe first let me check this free ptr, if the compile is stopping or not stopping, you can see. So same things, we cannot see the reflection. If memory will be free after that point, you are saying that we can free this memory part, but still your code can access that memory, but that will be the unsafe access. So let's free this like 2. Okay. Okay, it is showing warning but integer to pointer conversion passing in. Okay, this is actually value, not the pointer location. So what we can do, we can write the address like this. So now this is the address of the second element. If we free, still it will run the same. No behavior we are getting, but this is not the always case. Okay, so this is the unsafe things for our code. Okay, so you can free in this manner also, but it is risky.
So if we were to free in this manner, would that free, um, would that keep the first 2 positions allocated to PTR and free the rest, or would that do something else?
Mm, okay, so you are saying that PTR will remain allocated to the first 2 blocks. Okay. Yeah, the conceptually that memory block is free, and so what address we are giving, that the remaining part will be should be free, but we are not able to see this. Let me check the another compiler if any compiler will block this. Online GPD. Okay, so let's run this. Okay, yeah, it is stopping. Warning: free called on pointer PTR with non-zero offset. Free PTR 2. Okay, non-zero offset. So pointer. Okay, it is not supporting like this. So let pass this. Yeah, now it is running. PTR 1, 2, 3, 4, 5, 6. Zero to 9 to 10. Okay, yeah. So this compiler is not supporting this type of free operation. So we can only free this you with the help of the initial offset 0. So 0 offset means what is the base address. Okay, so PTR is the base address and the offset value is 0. Okay, so PTR that base address plus 0 is that means the address of the first element. So we cannot pass the PTR like which you said that from the second element like this. So with the help of PTR, and this is it is not supporting. So return from malloc this free, this is showing this warning, it is showing free call pointer with non-zero offset, and after that return value malloc, here also it is giving the error. This is memory allocation line number 17. Okay. Return from malloc. But this is error. It's written from malloc, malloc integer star ptr. So this actually compiler is not supporting this operation. So this type of operation do not try. Okay, because blocks should what block you have allocated at the runtime that should be completely deallocate with the help of pointers. So then this pointer will remain safe. Otherwise, it will work like as a dangling pointer. If you have free some part. Okay, so do not try this type of things. If if you want to free the so same way, if you want to allocate some part, if you want to deallocate some part, so the allocate the memory in the same way. What part you actually deallocate? So just allocate in the two different blocks. Then you can free. Okay. So these are some things regarding the experiment things, but according to the language specification, so that is not, it is not written anywhere you can deallocate the memory from some part of which is allocated by the pointer. Okay.
Yes, sir.
Yeah. Okay, so what another things you can try to explore if you have completed the second week. So you know that we are planning to use this STM, okay, STM Nucleo series of the controller. So actually every controller have reference manual. Okay, so like I'm sharing some reference manual document. What are the required information you should know? You can just start exploring. Okay, so like, yeah, so this Nucleo, this ST Nucleo series we are using, and this microcontroller is also given into the Walk-V simulator. So that some 3106 like this. So what? Let me check what Walk-V is actually using. Yeah, this one ST. Okay, so yeah, this 31C6. This and another is also there. This is the small one, but we are using this in the course. Okay, this microcontroller. So what are the reference manual for this? You can download this reference manual from the STM website, and after downloading, you can just start exploring the content. What actually like this? What are the pin diagrams? So what is this pin things? Okay, because later we will use this in our demo and code. So like some general purpose GPIO, basically general purpose input output pin is there, and what are the purpose of them. And also, so this is the data brief. One reference manual is also there for this. Let me, yeah, this is not. Yeah, this is the reference manual. Hmm. So this is the reference manual for the this STM32. So these reference manual are very important if you are if you want to working with any microcontroller. Okay, so here we are using this STM. So you should know about the reference manual, because many times you have to know about the memory mapping. Okay, suppose if you want to perform some LED blinking operation on this board, so you should perform some steps, like you should know what is the port you want to use. So like this in this diagram, yeah, in this diagram. So this is this A, you can see on the here. Let me take the pen. Okay, so here you can see the this A4, A3, A these things. Similarly, you have D. Okay, so this is actually called as a port. Okay, so what port you want to use, that port identification is required. Inside the port, what pin number you want to use, so like 0, 1, 2, 3, what pin number is required. After that, you have to enable the clock for this uh, pin, like you want to use this D7 for input and output. Okay, suppose if you want to use this D7 for output purpose. Okay, output purpose means you want to just blink the LED on this by this pin. Okay, so you should know the address of this D port, address of this memory map for this 7 number pin. After that, you have to enable the clock for this port. Then you have to enable this pin to the output. So this type of operation is required. So because every pin contains some registers, and that registers is actually have fields, like because if you have register for 32 bits. Okay, this is just a memory. Okay, so memory block for 32 bits stored. So 32 locations are there, and every bit or combination of bits have some specific value, like 0 and 1 for specific purpose. So like if this D7 contains the address and that memory blocks where the bit number 5 is representing the, if you pass the one value at bit number 5, then out, that means high output will come at this pin. If you change this bit value 5 to 0, so that means low value will come at the D7 output. So that type of information, what memory address is allocated to for this particular pin, that you can see only in the reference manual. That is not by default. If you want to code on the this microcontroller in the C language, and you want to access directly to the every part of the code, every port like this, so you should know what address is allocated for this pin. what addresses is allocated for the clock, then you can perform the operation. So regarding this changing bit, this 0 and 1, you see, you know the these operations, set bit and that clear bit operations, so which we have given in the programming assignment questions. So what address is given? So this address, you, if you want to change the pin value, this fifth bit to the 1, so you have to create the mask for that, and you have to perform the AND operation or maybe OR operation to perform this set or clear bit. Okay, so this type of operation is required uh, to perform any type of operation on this microcontroller. So you should know this bit manipulation concept very okay clearly. So you should know how you can set the bit and mask things, and you should also know the equivalent this binary numbers. Okay, suppose require the like, suppose if you want to set a first bit. Okay, so like you have one bit location, so like this, or suppose if you have this 1000, this is represent the 8 decimal number. Okay, this is the binary representation for this 8, and you want to set the first bit, this first bit to the 1, so you have to create the mask for that. So that mask will be like 0001, and you will perform the operation OR between these. Okay, so OR operation basically will convert this value to the 1001. So that means this bit is now set to the 1 high. So set bit means high, it is converted to the high. And similar way, you can reset, clear the bit with the AND operation, and toggle the bits. So these type of operation are required to interact with the hardware, this microcontroller. So this reference manual are very helpful to just know the address memory mapping things. So you can see if this is the basic diagram, or if you want to go in the deep, so that we have the another document like, so this is the another reference manual for the discovery board we have. So inside this memory map is given, you can see for every port, like you can see GPIO, GPIO-D, GPIO-D, what is the address, starting address and end address. So you can check the address for GPIO's pin. After that, for that, to enable this GPIO, some another address or registers are there, so general purpose, and this register GPIO registers. So every that pin have this 10 registers. So port mode, if you want to use that for input or output like this, so this registers actually contains the value in the bit. You can see the 32 bits, 0 to 31 in this range, you can see. Okay, so every registers have this 32 bits, and each bits have some meanings. Okay, so if you want to change, so in the previous example you can see, if you want to use that pin as an input, so you have to change the state 00. Okay, so this is the mode, which actually pin you want to use. You want to use mode 1, that 1 2, this is the for the 4th pin. So that you have to set to 00, then that pin will work as a input. If you want to use that pin as a output pin, you have to set the value like this 01. So to perform this operation, you have to use this bit masking. Okay, bit operation and all these things. So just practice on this bit masking things enough before the enter into the week 3, then this, the use of this bit masking will come. Okay, okay, so this professor will discuss about in more in the week 3. He will discuss about this, what is GPI, or this terminology actually, this what is clock, and what are the purpose of these things. Okay, but you can also explore these things before 3rd week. Okay, if you have done 2nd week, you can download the reference manuals and the data sheets for the HTM. Okay, so I'm not going in any deep because you haven't know about the controller. The professor will start in the next week.
Sir, can we get that all that PDF that you just opened?
Yeah, this is which I show you. The all sheets are not related to the this microcontroller which we are using. some actually documents are related to the discovery boards, STM discovery boards, that we are not going to use. So yeah, that we will provide you in week 3. We will release all the that sub documents just inside the supplementary content. Okay, and we will also release the I think supplementary contents are not available on the portal now for this course. Okay, not released. So we will also provide the PPTs. Okay, so for the week 1 and 2 and this documents in week 3. Okay, related document we will provide in the supplementary.
Okay, sir. Okay.
Okay. Okay, any doubt in programming question? Have you done the programming questions of this week 3? Sorry, 2. Well, only the one line codes are required most of the questions. So this shifting, right shifting, left shifting is required only, and this AND OR operation is required. Okay, so we will use this walk-v. So just also explore the walk-v things. So professor will explain about the walk-v also in the third week. Okay, any query, any question? If there's no question, then we can close.
Sir, could you explain about bit manipulation?
Okay. Okay, so bit manipulation operation actually performed on the bit of the value. Suppose if we have any value like this a equal to 10. Okay, so this is if we are writing int a equal to 10. Okay, so what is the equivalent binary for this 10 is, so that is actually 1010. Okay, and if we are using this int, that means initial all value will be 0. Okay, so like remaining 28 value will remain 0 for this. So we have this equivalent binary operation, and we want to perform, if we want to change the bit of this binary representation of this value. Okay, suppose if you want to change this bit 0 to 1. Okay, so here actually bit manipulation means we want to perform some operation on the bit, any particular bit. We can set the bit, we can reset the bit. So set the bit means we can change the bit. Okay, so 0 to 1 or 1 to 0, and we can clear the bit. Clear bit means if value is 1, then we will make as a 0, or we can check the bit what is the value of that particular that particular number of bit. So to set the bit, suppose if you want to change this first bit to 1, so what operation should be performed to change? Okay, so after changing this bit, what will be the equivalent value in the decimal? So if suppose if you change this bit to the 1, so what value will become 1011? So it is equivalent to the 11, correct? So this is the equivalent of the 11 in decimal. So how we can perform this bit manipulation operation? So we first things we will create the mask for this. Okay, so mask, and then to set the bit we require the OR operation. So suppose if we have this 1010, okay, and we want to change this bit to the 1, so we have to perform this operation like 0. We have to create the mask, and that mask will be like this. Okay, and then we will perform the OR operation. OR operation, if you know that what is the table of OR operation, so the OR operation table is if you have 0 0 0 1 1 0 and 1 1. Okay, so these are the combinations. Suppose this is the input bit, and this is A and this is B. Okay, and we are performing A or B, so what output will come? So OR operation means if first input is 0, so that means according to the OR condition, if both no, if any input is high, output will be high. This is the truth table for OR operation. If any input is high, output will be high. So here you can see both input are 0 0 means low signal. So both input are low, so output will be low. Here both input, one input is high, output will be high. Here one input is high, output will be high. Here both input is high, output will be high. Okay. So if any input is high, output will be high according to the OR. If for the AND operation, so for OR operation we use this straight line. For AND operation, we use this AND symbol. So for table, what is the table for AND operation is, so A and B. So 0 0 0 1 1 0 and 1 1. Okay, so these are the four possibility. So according to the AND condition, if both inputs are high, then output will be high. Okay, if, or we can say that if any input is low, output will be low. This is the AND condition. So here A and B, A and B. So 0 0 0 0 1 0 1 0 0 and 1 1 1. Okay, so this is the output of the AND operation. And we have the another operation XOR. So that XOR operation is A, B, and A, this symbol B. Okay, so according to the XOR condition, if both inputs are different, then output will be high. Okay, so 0 0 0 1 1 0 1 1. Okay, so this XOR operation is basically if both inputs are different, then output will be high. So here both are same, 0. Here both are different, 1. Here both are different, 1. Here both are same, 0. So this is the output. Okay, so these three basically we used. Another operation we have the negation. So that actually convert the bit into the reverse. Okay, so if suppose if we have this operation with 1 0 1 0, okay, and we are performing this negation operation, so it will invert the bits, all bits. Okay, so it will invert like 0 1 0 1. Okay, you will get this. So this operation invert all the bits of the value input. So to set the set any bit, you have to perform this OR operation. So OR is actually used to set the bits. If you want to set to 1, then you can perform this. So here you can see, if you want to change this first bit to the 1, so you have to create the mask for that, and you will use the 1 value in the mask at this location, and remaining are 0. After that, if you perform the AND operation, OR operation with this, okay, so you will perform OR operation. So 0 1, you will get 1, 1 0 1. You can follow this table, okay, and 0 0 0 and 1 0 1. So now you can see all three value are remaining same as the previous. Now this value is changed to 1. Okay, and after this operation, if you want to print this into the decimal form, so you will get 11 in the answer in the decimal form. Okay, so the operation is performing on the bit. So you can perform this type of operation like 1 0 1 0. So if you want to set this bit, you have to create the mask like this. So 0 1 0 0. Okay, at this location, at this position, you need this higher bit, and after that OR operation. So that will perform like 1 1 1 0. Okay, so it will become that 14 value. Okay, it is equivalent to the 14. So after performing this OR operation, and you are setting this bit into the higher. So this is required OR operation, and similarly you can also check the bits. What is the condition for the bit? So suppose if you have this 1 0 0 0, this is 8 actually in the decimal, and this is a binary equivalent, and you want to check this the second bit is high or low. Okay, so what you can do, you can perform the AND operation to check the bit, and to this you can create the mask like this. Okay, so 0 0 1 0. Okay, and perform the AND operation. So if this bit is not set, you will get 0 here. Okay, so if you are getting 0, so that you can say that this bit is not set. If you are getting 1, suppose if this value is like 1 0, and you are using the same mask and AND operation. Okay, so at this position, you will get like so this is 0 0 and 1 0. Okay, so to check this bit is high and low. If you are getting 0 output after performing this AND operation with this mask, So you can say that this bit is low. If you are getting this output, this is equivalent to 3. Okay, so so this is equivalent to 3. So if you are getting no, this is equivalent to 2. Okay. Yeah. So if you are getting this output, so you can say that that bit is actually set high. Okay, so you can decide your operation based on this. First things, you have to create the mask, and then you can check the output. What output? If you are getting this output, you can decide that. Okay, so another things, if you want to toggle the bit. Okay, so toggle bits means if you have like this 1 0 1 1. Okay, and you want to change that this bit. If this is 1, that should be converted to 0. If this is 0, that should be converted into 1. Okay, so in this case, what you can do, you can use the or XOR operation. So that operation is, you can set like this 0 0 0. Okay, so yeah, so, 1. Okay, okay, so and you can perform this OR operation. And if you perform this OR operation, what will happen? Okay, so the OR operation will perform here, the both are same. Okay. Okay, so okay, yeah. If both are same, then it will become 0, and this will remain. You can see this; these are the different. Okay, so it will remain 1, and this is 0, and this will remain 1. Okay, so remaining will remain. So all the remaining bits will remain as it is. And suppose if you are passing this input 1 0 1 0, and the same toggle, you can pass this like 0 0 0 and 1. In this case, that 0 will become 1. Okay, so 0 1 will become 1, and this 1 0 and 1. So same mask you are using. If you are using this or XOR operation, so this bit will change. Actually, if it is the input is this bit is 0, it will become 1. If this is 1, then it will become 0. So that means this bit is changing every time. So this is required some, if you want to just billing continuously any that LED. Okay, so that operation is required. So if you want to just billing, just turn on the LED, then turn off the LED. So what you can do, you can run a while loop, and inside that just use this operation. If the LED is 0, means LED is off. Suppose if this pin is the output pin of the for the LED. Okay, and if this is 0, that means LED is off. So after performing this XOR operation, it will become 1, and then LED will turn on. Okay, and inside the next iteration, this output will come in. This will come as input, and the same operation you will perform, and it will become a 0. So 1 0 1 0. That means your LED will turn off. So that will work like as a on off. That loop will run infinitely, and you can just give some delay in between, so you can see the complete difference. So yeah, that these are the main 3 operation you can check. Okay, and we have also given this programming question where you can try to apply this. Okay, but just perform the operation on the bits, because in the programming questions, the input and output is given in the decimal. Okay, like 10 is given, and some output is coming like 14 and coming. So don't see that how this 10 is converted into the 14. First thing, convert this 10 decimal into the bit 1010, and perform the OR operation or XOR operation as per the problem statement, and check what output is coming in the decimals. Okay, so what output is coming in the bit first. Okay, so bits, and convert that bits into the decimal. So that is actually printing in the output. So this is the cycle of the each programming problems. So we are giving one decimal, performing some bit operation, and after that we are printing the output in the decimal form. So this is the way. Okay, so this is all about the bit manipulation, and you can just explore more. Okay, any query in this?
No, sir. Thank you.
Okay. Okay, any other query from anyone?
No, sir.
Okay. Okay, then fine. If there is no query, then we can close.
So
Yeah.
there's a query I just posted in the chat.
Okay, let me check. I haven't got access to the embedded C course content. Oh, you're
The
asking
one
about
about
this?
no
Uh,
data types.
okay, Prof. Video told about the using the smallest data type for variable index. Will it support value of the given HTML manual? Yeah, okay, so this data types regarding, yeah, that is also important things. Because of that, professor have suggested to use this std int library. So what happened actually, so let me share again. One second.
So the question is, how do we find out the supported data types? Is it is it board specific, or is it something to do with the compiler? Where do we go find out the supported data types?
No, supported data types are the same that we used actually for the normal C, that integer, that long, all data types are supported.
Uh, but he's using some specific things, underscore T and all that.
That I'm just explaining that. So what actually happened? So you know that the C data types, you have learned this char, okay? Char, then sort, then int, and then if you want to use more, that long int, okay, and then long int, okay. So what happened actually, some memory is allocated for this data type. So char is actually is also a integer data type. Okay, this is not for the char, but some mapping is happened using this ASCII codes. So suppose if you are getting the a value in the char, so the equivalent binary, some value is assigned for this. Okay, this is 65 value is assigned for that. Okay, so char is the smallest data type in C. That is the size for this is 1 byte, you know. Okay, sort is the next integer data type that contains a 2 byte. Okay, integer contains uh, minimum 2 bytes, but in some case 4 byte also. Okay, so same things for the long. So long is also some place 4 and some 8. So what happened actually, C have just declared that this is mentioned that in the C the character should be 1 byte, short should be minimum 2 byte. But this integer and long int, this size is minimum sizes and maximum size is defined by the C, but not the fixed size. So this integer long int is actually dependent on the compiler. Okay, dependent on the that what compiler you are using. So some place you will see this int int is allocated 4 bytes, but some place you will also find out that it is only 2 bytes are allocated for the same int data type in the C. So how you can decide that? Because if you're writing the code for any one machine, and if some later if that compiler is changed and machine is changed, so maybe the size may also be changed. Okay, if you are using this int, okay, and you are writing the code for the 4 bytes purpose. Okay, so you are assuming that int is allocated 4 bytes, but if the same code is running on the machine which is actually only allocating 2 bytes for the integer, so there is a chance you will get the error and you will get the some buggy things in your purpose. So because of that, this std int dot h library is actually there, which is used in the embedded system. And this library what actually does, uh, here you can use this type data type like int 8 underscore t. Okay, so what is the purpose? So this is just a alias, this is just a, given as a name. And here if it is if you are using this int 8, so doesn't matter which compiler you are using, 8 byte will be allocated to you. Okay, so if you are using 8 byte, 8 this int 8t, so 8 byte will be allocated for this variable. This it doesn't matter which compiler you are using. If you are using, so same things for the int. So if you are using, if you want to use int 32 underscore t, okay, so here it is mentioned this 32. That means 32 byte will be allocated to your program. Okay, so 32. Okay, here if you are using any compiler, so doesn't matter what the compiler is allocated to the int. If you are using this data type, 32 bytes will be allocated for your program. Okay, so this is actually defined inside this std int.h. here some type defined. If you know that you have already used this malloc dynamic memory allocation, which where you can use this, no, not this structure things. Okay, you have used this struct, where you use this for operation type ty type def. Okay, where you can just change the type name. Suppose if you are using this student structure, and you can use change the name of this student structure to s. Okay, and later in the code you can use this s place to create any structure of this type student. Okay, so same things is used here. So if you are using this int 32t, okay, so this is actually written here int 32t. Okay, so required 32 bits are allocated. So what are the type should we come here? So like if the compiler is like, what you can do, you can write like this type int. Okay, and int 32t. So here, what if you are allocating the memory, if you are creating any variable with the help of this data types, so that will allocate the size int, and this is defined compiler wise. Okay, so if you are using this stdio.int h in some compiler, and that if that compiler use the 32 bits for the int, okay, so that will be allocated for you. Okay, so that int will be allocated. If any compiler, if suppose any compiler use this 16 byte for this int, okay, so this command will be different for that. So in that case, in that compiler, this command will be like this. So type this, maybe you will get like long int. Okay, for
Excuse me,
int
sir.
32 underscore t. So 32 bit will be allocated. So suppose this is taking 32 bits, so that will be allocated. Okay, so that cross compatibility will not be not create any problem if you are using this as standard type.
Excuse me,
Yes,
sir.
yes.
So thank you, sir. That was a clear explanation. So, sir, you mentioned that it will vary according to the way the header files are defined.
Hmm.
So, for example, in this STM32,
Hmm.
the particular tool set that we are using, right, for developing this, so that's the place where to go and look for the specific data, right? In this, I
Yeah,
mean, which, let us say, instead of walkwe, if we are trying to compile it ourselves using the board, actual board.
actual
Let's say
board.
we're
Okay.
buying a board and then we're compiling it.
Yes.
So at that time, we can't use GCC, right? So we might have to use some specific tool set given by the manufacturer. How does it work, sir?
No, instead, if you know the QID, STM have this QID, if you know.
Okay, this is
Okay.
what I want to know,
Yeah,
sir.
this is the QID. Still, same things. What data type? So this is one code is mentioned for the LED blinking here. Okay. So here, same things. You can use this std int by default. So here we are also using this mingw compiler in the backend of this. That
Oh,
compiler is actually added.
okay.
Okay, so
Okay,
that compiler is added. Accordingly, this stdint.h will convert the required size. So suppose if you are using the 32.int, 32 bytes will be allocated. Doesn't matter how much size is your compiler is taking for int or sort or like this. Okay,
Got
so
it,
this
sir.
is for the fixed
Got
byte.
it.
Yeah.
So instead of MinGW, we can link connect it to any other compiler maybe.
Another you can also, but by default it is mingw actually linked
Okay,
for this QID.
fine, sir. Understood, sir. Thank you, sir.
Okay. Okay, so bit2 Kumar is mentioned. Sorry to interrupt. I haven't received the code content access. Okay, so bit2, I am noting down your roll number. So I'll check this. Let me check 1 second. Noting down 1 second. So I've noted down your roll number. I'll check with this operation team. So how you're not getting the access. Okay. Okay. So any
Sir,
other? Yes.
yes, sir. Just one question. So in this embedded C course, will we get a chance to use the STM cube directly, or will we entirely be working with Walkway only, sir?
You can use, if you have the physical hardware, okay,
Yes,
then
sir.
you can use this cube ID, STM cube ID, and you can just create the code, and you can upload the code on the microcontroller and then run. You can, that cube ID have also contain lots of feature. You can check all the assembly code, you can check all the memory map you can see about all of the microcontroller. But that feature, that this is very high featured ID. So, but this is required, this physical hardware.
Yes, sir.
If you have physical hardware, definitely you can just explore this.
Fine, sir. Just one more question, sir.
Mhm.
So, Professor explained about bit banding. He explained how this, for example, 1 MB of area is mapped to some 32 GB of address space. So now these details will be given in this STM manual that you showed, right?
Yes, yes. Every mapping information you can get from the manual.
Okay, because I did download the manual, but maybe I didn't know where to look for it.
Yeah, yeah. That things actually will be discussed in the Week-3, where the professor will discuss about this data sheets and manual like this. What
Fine.
information is required, where you can see. Otherwise, in Week-3 or Week-4, we will also discuss about the reference manual, so where you can see this
Fine, sir.
information.
Thank you.
Okay. Yeah. Okay. Any other query? Okay, then we will meet in the next week. Thanks, everyone. We can close the session.
Thank you, sir.
Okay. Yeah. Bye.
Thank you, sir.
Thank you, sir.